So Markus just gave me access to his laptop, so they will just take a minute. Everyone here who has been to SuriCon before will know Markus. Markus has been talking many times. I think, have you been?
Once.
Right? Oh,
Once.
okay. Sorry, in my mind it's much more often. You've been to SuriCon many times.
I have been to SuriCon many times.
Yeah, all right. Markus used to work for NATO, the Center of Security Excellence.
Excellence.
Yep. But now has joined Peter and Eric in Stamus Networks, doing many things around Suricata, and so I'm very excited to see what Markus has come up with. The Jupyter playbooks are something I've always meant to look at myself, so I'm very excited to see what Markus has been developing. So please, a warm welcome for Markus.
Hello. So, as Victor said, I'm Markus Kont. I come from Estonia. You can find me on GitHub and Twitter. I don't broadcast a lot. I kind of come out of my cave every now and again and do a brain dump and then retreat back into my cave. So I'm not super active on Twitter or anything like that. And yeah, I'm the guy who will be keeping you from lunch apparently. Sorry. So what is Jupyter Notebook? That thing. Okay, in conclusion? Okay, not really. But I do have actually a lot of stuff to cover, so I will be moving forward, and I might be moving forward at a very fast pace, but I will explain why I'm doing it. Alrighty, so just as an introduction, so the goal of this talk is to introduce notebooks. So it's not really meant for experienced data scientists. If you're very experienced with it, there's probably not much new in it for you. It is basically Jupyter for meerkats. And those of you who have used it, I hope you will find some interesting stuff here. Those of you who have no experience, I am sorry, it is going to be a very fast brain dump. But I will. It is focused very much around Suricata, so all data I will be talking about is actually Suricata data. No iris data set, data science dump, nothing like that. And I might not cover everything because time is limited. I have a lot of stuff to do. This actually should be a workshop because there's just so much that can be talked about in here. But the important thing here is that this presentation is meant to be a resource for the community. And what this actually means is my presentation is a notebook. And that notebook will be public in an open source project by Stamus Networks. Currently it's in MR. I need to wiggle a few things. But I will merge it into a public repo. Everyone can clone it. Everyone can run the notebook and use it as a resource when playing around with it. All code, I am really tempting my fate here because everything is going to be live. It is a big tech demo, so I am already using my own 4G just in case. But it should be fairly minimal in terms of data input. I hope you can see it. If you want, I can zoom it a little bit more. I'm just trying not to zoom too much because you will see in just a minute. And yeah, it's a live demo. Things might blow up, so pay no mind to stack traces. I will have a static version of this just in case that I pre-ran before. But I hope I don't have to resort to this because it's much cooler if I just run everything live. So a few words about me. I already got an intro. I've been in the industry for a bit over 10 years now. Did my cybersecurity master's back in 2014, which feels like yesterday. So I think that means I'm getting old. Got a few gray hairs in my beard already. I spent some time in the PhD studies, never finished it because academia really was not for me, but just as a context why I'm talking about the stuff I'm talking about. Data analytics and log processing was stuff I kind of focused on while there. And I also, as Victor mentioned, worked in NATO CCD COE as a technology branch researcher. That's how I met Eric. Eric was helping us with Suricata training since 2016, so I've known these guys for a while. Later I came to SuriCon, met Peter, and since 2020 I've been the resident math scientist in Stamus Networks. Since last year I'm also a full-time dad, so working from home, fully remote, COVID lockdowns, and raising a baby who's now a fully fledged toddler. I haven't really gone out much recently. So, yeah, I haven't done a live presentation in front of a stage like in a while. I consider myself a hacker, not in terms of like hacking systems. I prefer building to breaking, but I don't really think about stuff in terms of like how they're supposed to be used. I think in terms how they can be used. Okay, so meat and potatoes. Let's talk about Jupyter. So what is Jupyter? Jupyter used to be called IPython notebooks, meaning, IPython interactive Python terminal where you can write code and you get instant response. So you don't have to write a script and run it in an interpreter. You can write a line of code, enter, boom, output. And this is just a web application version of that. It got rebranded to Jupyter because, branding is important. And it is a de facto tool for data scientists when it comes to like data analytics, things like that. It is taking over. Data scientists who used to do things in R are now doing it in Python using notebooks. But, a notebook has a concept called a kernel. Kernel basically is what is running the code, and it actually supports many kernels. So you could run actually other languages as well, but I'm going to focus mostly on the core Python stuff here. Okay, so pip install. So meaning, let's do a little bit of a intro to notebooks. So notebook is organized into cells. Cell can be code or markdown. So right now we are actually looking at markdown cells, which I'm kind of using as pseudo slides. Don't worry, Kelly. I can actually export this as a PDF file. So I might need to install some packages, or I might need to export it as HTML first and then into PDF, but I can do it. So don't worry about that. What I'm actually using here isn't the core notebook. It is Jupyter Lab, which is more of an IDE-like environment. You can see I have a nice side window here, so there's an outline of everything I do. I can navigate my file listings here. I have tabs. I have all this kind of nice stuff. Setting it up is super easy. Pip install. And so likewise, starting it up also super easy. Just Jupyter, optionally Lab, and then you can just grab the connection token from the output, which is, well, this is the reason why I don't want to zoom it too much, because I have a lot of examples like this. Don't worry, the stuff coming is going to be actually live. But you can just grab this. It's meant to be single user. There's a multi-user versions, but I'm not going to get into that. That's already kind of getting beyond the scope of here. Okay, so it's SuriCon, so let's start with a PCAP file. And I'm just going to, what I can do here is let's download a PCAP file that is going to be my input for everything I'm going to be showing from here on out. So I can just run this cell to import my Python libraries. I define the input and output. So I'm going to download this malware traffic analysis PCAP of some web scanning and log4j exploits. Which isn't super interesting, I know, but it has a decent sample of data for me to show off Jupyter with. And there's some cool stuff in there as well. So you can see I can just write Python code directly into a cell, and I get instant feedback, and I can modify the feedback really fast, so it makes it very easy to just like, makes it very, very convenient for fast prototyping. So I'm just going to unzip my file because I'm lazy. I don't want to write stuff into console, so, just like password is infected and whatnot. And now I can validate that, yes, I have this folder here in my temporary directory, and just like get a nicer look at it as well. Now, I cannot talk about a Jupyter notebook without talking about pandas. They really go together. So what is pandas? I actually skipped over one cell. So I can also invoke some magic commands and shell commands, which will be super important because I also need a rule set to work with. And I don't really want to write Python code just to call suricata update. So I can actually use a built-in pip function to install stuff. So I actually have suricata update installed, but you can see the output. I ensure that I have everything set up. And I'm just going to call some bash commands to enable some extra rule sources. And now I'm going to actually download a rule set as well. And looks like, yep, everything went well. Yes. Yes, okie doke. Just do a little bit of cleanup, and, well, what do we want to do? We want to run suricata on a PCAP, which is I can do pretty conveniently. I cannot put a variable in here. To do that, I would need to write Python code, but for what I need to do here, and let's say if you wanted to do some kind of forensics or data analysis on some PCAP files, you can actually very easily just call suricata from a notebook. You don't really need to switch from the input, which also means you are able to package up the entire hunting or forensic logic into a notebook. And it will store results. Actually, I can export this notebook, and it will store the output, everything in here, into the output PDF. GitHub and GitLab are even able to render the output very nicely, just like how I'm showing it here live right now. Okay. So what is pandas? I kind of hopped into here a bit too soon. Pandas is a library that gives us data frames. Why? Because, well, JSON is nice if you want to look at individual documents, but if you really want to explore data, you need row and column format. And this is basically what pandas gives us. It is basically implementing what statistical languages like R do natively, which is just give us matrices and vectorization support. And actually, pandas is a higher level version of what we need to do here. So I'm just going to import some libraries, and I'm gonna show you what a data frame actually looks like. So this is a data frame, so you can see it even renders very nicely in a notebook, so I can actually get a very good, it has a very good information density, which is what I care about. I can see a lot just visually. Okay, but I mean, this example is boring. Let's do some Eve. So pandas is not just a library. It is almost a programming language. You kind of need to unlearn some things you are used to doing in a regular Python if you want to use pandas, because it has methods for freaking everything. But one of the coolest ones that I really like is JSON normalize, because Eve is fun. Eve has so many fields, and going at it manually is a challenge. Well, luckily, I can actually just load my Eve records using core Python, and I can use pandas to normalize the fields. So you can see here, for example, all of these are actually nested Eve fields where the column names are now basically a concatenation of the JSON keys, bloomp. And I have all of the rows that I have all columns that correspond to individual Eve fields, which is really nice. Alrighty. And yeah, and I can actually start using pandas to get like a bird's eye view of the data. So I can take a look at the shape of my data frame. I see I have almost 26,000 rows, and I have 557 columns of data. And I can also use core Python to basically measure the same stuff. And I can, most importantly, I can start using core Python to to start modifying my output. So I don't care, for example, about stats for now. I just want to see the hunting data that I can use. And I can just use like a quick Python list list comprehension to just exclude everything from the stats category. I see I have 120 unique fields that I can explore. All right. Now I'm going to go through a typical hunting case and just to kind of show you how to do it with a notebook with pandas. So what I want to do, I want to prepare my data. I want to locate something interesting. I want to subset it so I can view just the stuff that is actually relevant because there's like 120 columns of data. Like that stuff is not going to fit on stage. Trust me, at home I have a like 4K screen. Those columns do not fit there. You need to drill into something interesting. And then you need to pivot to something relevant. And, well, then we can get some really cool stuff going. So, preparation. I can actually do a lot with pandas. I can parse the timestamp into an actual timestamp object, which lets me later do a lot of stuff with aggregations, for example. But I also need to do stuff like normalize things because this is coming from the scientific community, meaning every number by default is a floating point. Why? Statistical analysis is done on floating point stuff, which means if you start looking at some stuff like flow IDs that are really long integers, if they are stored as floating points and you just want to do simple thing like copy a flow ID into like a lookup, all of a sudden you get a scientific notation of a really long floating point number, and that is not nice. But you can easily cast stuff over. So this is what I meant when I said pandas is almost like a programming language. It has methods for everything. I'm not writing loops of code. I'm not writing my own logic. I'm just saying, okay, so the flow ID column, in the data frame, select flow ID column, fill missing values. That's important because our missing values are a thing, not the number. That's a fun thing to deal with. Fill it with zeros because we have stats in here. Stats do not have flow IDs. That is something we need to deal with. And then cast it into int. Okay. Next up, we want to find something interesting. So since this is Suricata, let's start with alerts. And again, just I can say, give me all rows in a data frame where event type is alert. Ignore that protocol decode stuff for now. I don't want it for hunting. Sort it by timestamp and drop all columns where I don't have any data to limit the stuff that I actually have visible. And then I'm just going to subset it by selecting stuff that is just relevant initially for exploration, timestamp, the flow IP pair, flow ID, because I want to pick up something interesting right now. So for the next step, I want to see the signature, I want to see the category. Okay, and boom, I get this kind of view, which is, I prefer this kind of view to JSON events. I know others might prefer something else, but sure. So what I want to drill into here is, okay, so I see I have a hunting alert on a log4j output exploit. So I'm just going to copy this flow ID in here, and I'm actually going to, I actually want to pivot of that. So I can actually give a notebook some input. There's a built-in magic function called input for that, which is not super powerful. I will show you some cooler stuff down the line. So I can just tell it, okay, I'm interested in this flow ID, so let's do a subsetted data frame of only the flow ID events. Basically, I'm going to do flow correlation. So anyone who has used Evebox will probably recognize this. So basically, here I have give me all rows from the original data frame where the flow ID is the one that I just selected. And again, drop all columns that don't have any data. That's important because I don't know what I'm looking at yet. There are so many fields in Eve that it's basically it's really difficult to figure out like, okay, where do you want to go? Well, actually, nice thing about this is I can very easily now get an take of all rows where I actually can look at some data, which is kind of cool. And so what I'm going to select here is actually, okay, so I have alerts. I can see that I actually have some HTTP fields in these events. So I want to see the exploit data because I might want to do some forensics. I want to do incident response. I want to see what was actually done. So again, I'm going to subset the data frame, and I'm just going to look at the columns where I'm most likely to find an exploit. And sure enough, yeah, this looks exactly like what I'm after. Alrighty, so next up, well, again, I can just use some built-in functions here to extract, because the view is limited, right? There's only so much screen real estate. So I'm like, okay, I know I have interesting stuff here in HTTP URL and refer fields, so just show me unique values, and yeah, it's a simple example. There's only one example in here, but this is nice. But that's not the end of the road, because if I was a SOC analyst, I would need to write a report about what actually happens. And this is where things kind of get more cool, because I can create new columns of data into my data frame. And yeah, I can, what I would need to do is I can actually write custom code to kind of extract some interesting stuff. So right now, what I want to do is I want to extract the actual base64 payload, because I need to understand what actually happened, like what is going on inside this blob of base64. And I might want to do it on top of my, a larger data set, not just the one that I found, but actually I want to see everything. All right, so here is the part where we really need to start unlearning the stuff we know about programming. Forget about for loops. Just don't, forget it. What you want to do here is actually use something called apply, which means write a function that is being applied over an entire column of data. So in this scenario, we're actually doing string processing and extraction using Python code, so I'm expecting the performance benefit isn't that great. But if this was actually numeric crunching, if we were doing real statistical analysis, then using apply versus a for loop is orders of magnitude faster, because an apply function is basically a SIEM vectorization command that is executed low level by the backing C++ vectorization stuff that is using actually. No matter how good you are at writing code, you are not faster than freaking CPU instructions, okay? So just unlearn some stuff that you've known. But as a bonus, it also means that the code is very linear, and it also it's clean, it's step-by-step, it's good for reports, and for a reason, because this is coming from academic communities. You want to do step-by-step, and you want to basically write a paper. And guess what? This actually, in my mind, fits perfectly well also to incident response. Okay, so the next step, we have a column of data where we have extracted the base64. Well, decode it. So again, I'm just going to import stuff from core or Python, apply a function, a function or a method with a single argument. I will not tell anything here. This will actually implicitly just apply on the data that is in the column. And I will also, just string processing, right? And as a result, what I end up with is, if I take an outtake, I see that, okay, so this is the base64 that I decoded, and this is the sweet stuff, okay? Again, not the most super interestingest thing, but let's say if it was a Windows exploit and you see something like a PowerShell encoded command flying around on your network, you're going to find some really funky stuff there. So, and I now have this decoded to all, to all of my data. And what would an analyst want to do? Well, dump it. I can just say data frame report to CSV into the report.csv, because, well, not only academics like CSV files, I think managers also like CSV files, because you can just import stuff into Excel. So, and here we basically have, okay, so here's what happened. So here is the outtake that we need as an evidence with the actual malicious stuff decoded already. Alrighty. So next step, so this is just a quick, just a simple walkthrough of a hunting, but I also want to show you some other cool stuff that can be done with pandas and notebooks. And there's a lot that can be done, starting from aggregations, getting into visualizations, actual data science methods, and something called widgets, which I really like. Now, this is a very quick run-through of just like some cool things. So it's, as I said, like this could be like several days worth of workshop just to kind of go through this, and you're getting like a really, really rushed version of it. But as I said, I want this to be a resource that people can use later. So we took the long way route. If I use pandas, I can actually just call aggregation. So what I can just say is, yeah, like do some filtering. I can use the group by method to say that, oh, let's group by signature, and then give me the smallest and largest timestamp. Remember, I converted timestamp field to an actual object. So I can do aggregations. I get first seen, last seen, which is very relevant if you're doing threat hunting. How long have I been compromised? And also, okay, show me the unique URLs. And actually, you can see that the malicious URL is just visible here when I just look at unique data. And I also get a quick count as well, like not the count of URLs, but the count of events that have this URL. And this is what I like, the information density, like maximum amount of info in the smallest amount of space that I can occupy, because all of a sudden you're able to see a lot by just glimpsing at the data frame. But, well, we can get into sexier stuff, so obviously we can visualize this as well. So, you know, everybody likes bar charts, so here's a pie. Not terribly interesting. You probably still want to do this kind of stuff using Kibana, because this is not, you know, this is all in-memory processing. Stuff is limited, so yeah. Should I use this instead of Kibana? Not really. But what you can do here, and I was actually thinking about this in terms also when in the first presentation when Zinc was talked about like how the front end hasn't really caught up yet. Well, guess what? With this kind of tooling, you can actually create some very cool data aspiration on top of backend that isn't fully fledged out yet, that might not be on par with the front end yet. That is kind of the motivation also why this project I'm showing you here came to be in Stamus. So, okay, coming back to this. So I wouldn't want to use this so much instead of Kibana, unless I just want to get a quick processing. But I can start looking into numbers. I can start doing stuff that Kibana cannot do. So I can do a scatter plot. So let's say if I want to look into something like bytes to server, bytes to client, I want to see heavy hitters. I want to do some purely statistical stuff to actually like separate the large quantities of data. Then all of a sudden, boom, I get this view. And this is interesting. I can see there are a couple of heavy hitters. I'm interested in who those guys are. I might be also interested in who those guys are. So, you know, everybody's talking about machine learning, how it's awesome or how it sucks. Doesn't seem to be anything in between. So this is my take of the in between. It is not going to save the day, but it is a very useful tool when applied properly. So if I want to figure out who those guys is, I could actually just use for example, something called k-means, and I'm not going to explain what this k-means because I need like another hour or so just to go through it. It is the most basic clustering algorithm in the data science toolbox. It is super useful. In fact, in Stamus, we're also using it in our product now because all of a sudden we're able to dynamically figure out who are the heavy hitters. And we might not want to do it to actually report the heavy hitters. Mostly the heavy hitters are kind of boring. What we do at work is actually we figure out who are the heavy hitters, we get rid of them, and then we do it again. because the guys at the bottom are the really interesting ones. And traditional databases like Elastic are not very good at reporting what is at the bottom of the data set. So we can start doing stuff like that. So what does this give us? Boom, I have actually, so yeah, here I'm just coloring it, but actually this is a new column of data. I have a cluster ID. I can just go back to my data set. Give me all flows with cluster ID, for example, 3, or whoever is painted red, and I can actually see a lot, and I can dynamically split my data and just like make things easier to shift through. So this is mathematical matplotlib, the default plotting in that Pandas uses. It's meant for academic papers, so not really, maybe if you're coming from Kibana, you might want something more interactive. Guess what? That also exists. So there is a very cool project called HoloViews, which is a drop-in replacement for the default matplotlib that gives you a much nicer view and much nicer stuff. So for example, I can hover over stuff here. I can pack in more data. I can attach stuff like, I can see flow IDs. I can actually zoom in or out, for example, if I wanted to. I can move around, and it's pretty cool. And it also actually supports some built-in grouping, so I might not want to do data science, I just want to do group by. So if I wanted to get a picture of like, give me colors based on the application proto, for example, then I can already see like a very different but probably relevant view of the data. Again, very useful. Now, I understand most people who would be analyzing this data are not coders, and even if you are, then writing this custom code can be very cumbersome. So luckily, some people in a little company called Microsoft figured out as well. So there's a very cool project called Mystic Pi. It is developed by the Microsoft Threat Intel team, which is actually a Python library to enrich, to visualize, analyze data, and just to make it easier for an analyst to actually use a notebook. So for example, the guys took a look and said, nobody has actually implemented an easy-to-use timeline graph. So they did it, meaning I can just pass a data frame of stuff. I can say I want a timeline based on signature ID, for example, and I also want to pack in some extra data whenever I hover over. I want to see source and destination IPs. And this is interactive. And it can actually do a lot of really advanced stuff as well. So, oops, no, I do not want to click this button, because that would restart my kernel. That would be bad. So a first scene, that's not super advanced, but this is like a first scene, last scene event. So how long has something been going on? Boom, again, using tools like this, all of a sudden, you can see a lot very fast. Okay, and the final thing that I think is super cool that I will demo also later is something called widgets. So again, right now I'm just writing code to explore stuff. But really, and this is very relevant if you're writing a report, because then you need the output as well. But if I'm just, threat hunting and data exploration is not a linear process. You need to go back. You're like, this is a dead end. I need to go back and look at something else. So there is a very nice library called IPy widgets, which basically allow you to make a notebook fully interactive. So how this works is I define a handler, and this is just a very simple example. I have a very complicated one that I will show you, not in the code, but at least in the usage. But this is just like, okay, it's just taking some kind of global data, it applies some filtering and transformation, and it returns the result. And why? Because I just want to explore stuff. I don't want to do anything fancy like save anything anywhere, but on a basic level, it's actually very easy to use. Like at first, like if you just look at the stuff on the documentation, it can be a little bit daunting, but actually it's fairly straightforward. You just call this interact or interactive if you want to save it as a variable and package it in some kind of like a nicer look. The first argument is the handler, and the next arguments are going to be the actual widgets that correspond to the arguments of the handler function. And what I can do here is I start defining widgets. In fact, I don't even need to define widgets. It will kind of auto-detect what I need. I will run this guy really fast. Because you can see, I did not say I want the text box here, but the interaction handler had one look at, it's a string field. OK, I'll give you a box. I do define my own widget here because otherwise, the min and max are going to be like -50 to 50 or something like that. And I also want to do something like select columns. So for example, so coming back to the log4j exploit, if I just write JNDI, which is the IOC for the log4j, boom, I actually have it really fast. And I can do all sorts of things. I can add columns of data. So for example, this is a little bit small, so I'm just going to click on button so I can select, for example, I want also to see the event type here. I just click it, and now it's also visible here on the data. It exposes a lot very easily, and I really love this stuff. And also like just a demo widget here, there's like some really useful stuff. So here this supports like partial completion, for example. So I can, for example, select something, doesn't have any events for that, but still, you kind of get my drift. So I can say 195. What is the IP? .54.160. Well, I mean, you kind of get the idea here. And also, view of stuff is limited. So, for example, what this allows me to also do, the limit view, you can see that the data frame is actually truncated. There are 2,400 rows here. That's going to be a lot. That can actually kill your, that's not going to kill my browser, but if I had hundreds of thousands of rows, I would not want to print out this data frame because kaboom. But I can do it so that I can expand and collapse the view. OK, so just a few. So actually, this is almost done. So as I mentioned, this is all going to be up on Stamus Networks GitHub. We have started a project called suricata-analytics that will also have some other cool notebooks for data exploration, for hunting, kind of to expose more EVE data. Because when we started looking at some interesting stuff, for example, in the SMB space, then we kind of saw some things that look really weird, and we're like, OK, so is nobody actually looking at this? Yeah. And so what does this project actually have? It has notebooks themselves. There's a small Python library to make it easier to ingest data from our open source Selks application. This here, everything I'm showing here is actually inside a Docker container. So I have a Docker container that has already pre-packaged some really cool Python libraries for data exploration. It actually builds the latest version of Suricata. It has packaged Suricata update, fixed all the permissions, so you can just like Docker compose build. We don't have anything pre-packaged right now yet because it's a big boy container. It is definitely, cloud-native people would definitely hang me or something if they looked at the amount of stuff that I'm cramming into that thing. So you kind of have to build it for yourself for now. But it doesn't have many notebooks, but one thing, for example, is I mentioned widgets. So I made this thing. I'm going to zoom out a little bit because otherwise it's very inconvenient for me to actually show. Maybe I'll close this as well. So what does this actually do? This is actually talking to Selks. To our web application, and it's basically just proxying requests into Elasticsearch. So, and you can see there's a query filter, which is actually something you can quickly lift from Kibana. It's Elasticsearch query. Give me all documents where event type is not flow and event type is not stats. And you can also set something like, limit. Oh, yeah, this is actually view. Limit how many documents you want, up to 10,000, because 10,000 is an Elasticsearch maximum. I can just say download EVE, and this will actually pull the EVE documents not from a log file, but basically through a REST API that talks to Elasticsearch. And I can start exploring. So I can select interesting fields that I am interested in. Just like how I showed you before. So I have a lot of interesting stuff in here, for example. I might want to apply some sorting functions, so like sort based on this or that column. Multiple are supported. Quick bird's eye view, just on like what kind of event types are available. I can dig into maybe only specific event types and expand the view as well if I want to. Let me just select something like alert signature really fast. And I can actually get a quick bird's eye view of the data. I can also aggregate stuff. So now let's group stuff based on flow ID, for example. I can say aggregate. And yeah, stack traces are normal. Yes, because I forgot to actually add a flow ID. So if you do try to use it and you get confusing traces, please, make an issue. It is not the most smoothest experience. It is not meant to replace something like Splunk, for example. This is really just to open up more into Eve, right? And now I am able to do something like explore alert signatures, for example, and per signature I can see stuff like unique source IPs, unique destination IPs, unique flows, well, anything I actually want. I can simply select the columns. I can draw timeline, just for example, for the signatures. So I can click draw. I can change the rendering here as well, because otherwise, the signature names are kind of long. So the rendering might not work. So here is one of the unique new REST API endpoints I actually added into Selx, because before coming to Stamus, I tended to use Archime or former Moloch a lot, and it has one feature I really love, which is just a simple list of unique values. And for some reason, you don't really have that kind of stuff in many analytics tools. So I added this. So this is actually not crunching the raw Eve. This is actually talking to the Elasticsearch in the backend. So I will just do a quick example. So let's say I select HTTP URLs, and I want this kind of simple view. Why? Because I might find a Christmas tree in my logs. Yeah, and there's a ton of cool stuff here. Graph mining, that can be like a big workshop in and of its own, but for example, I want to see source IPs connected to alert signatures, and this, I can pull some data and I can get this kind of view of the data. So this isn't a very interesting PCAP, but let's say some internal SMB stuff that we looked at. Yeah, you can actually start doing some really interesting profiling when you start using techniques like this. And we can even extract IOCs if we want. Like I'm not going to touch this because this can be wonky, but if I select something like payload printable, I'm actually using one of the features in the Mystic Pi library, which is IOC extractor, which is just a function that will basically brute forces data using regular expressions to extract IOCs. So if I take just alert printable payloads, I can actually build a data frame of possible IOCs. It's not perfect, but actually there's a lot of sweet stuff that is inside the payload of an alert. Okay, so I'm pretty sure I'm out of time at this point, so I'm just going to say thank you. So as a takeaway from this, this is just a new tool in the box. I'm trying to promote but not evangelize, right? I'm not saying, forget Kibana, forget Splunk, now this is how you need to do it. No, this is just, this is something that you can actually use in the open source space. You can do a lot. There can be a very high learning curve, and this is something that I'm trying to kind of help with this presentation, to kind of get people who have not done it, or maybe even who have used it but found that you're basically not very productive at all initially when you touch it, to kind of get over some initial humps along the way. And one of the reasons why the suricata-analytics project exists is also because I kind of need your help, because we have a lot of ideas at work, and we would really like to test drive these things faster. And one way we can actually do it is by providing notebooks that you can use on our open source version, so you can actually give us feedback. Yes, this is actually useful, this is not, this is cool, but the interaction is really funky, or along those lines. Maybe even contribute some cool notebooks to us. So I'm just going to inject that thing right over there. And yeah, so thank you.
So that sounds like a joint webinar or continued learning or beers down in the lobby bar later kind of invitations, all the above?
Yep.
And we won't
Any
talk
and
about
all.
you going over time. It's okay. We'll adjust. Okay. Questions?
Hi, I was just wondering which library is used to render these graphs that you showed.
Can you repeat, please?
I was wondering which library are you using to render these graphs, and are these static images or is this interactive?
You mean the graphs that I was showing?
Yeah, exactly.
That was the HoloViews library that I kind of like, I know it like went over it pretty fast, but it's, yeah, it's called HoloViews. It can do quite amazing things. In fact, I mean, it was HoloViews plus the Mystic Pi wrapper, which is actually just a wrapper around HoloViews. So actually, what I recommend doing, so this is the resource to this data visualization library, can do crazy things. But actually what I recommend doing is Google something called InfoSec Jupyter Fun. It is organized by some of the guys from the Microsoft Threat Intel team. They have very nice two-day presentations about basically everything I just told in 45 minutes, including the data visualization part. In fact, the event is going to happen again in the beginning of December, I think. It was like this has been like a big inspiration for my talk as well, because all of the talks there are actually notebooks. And you can actually find a lot of very useful resources into all of the notebook stuff here in a much more detailed version that I just did right now. So I highly recommend checking it out. But yeah, short answer, HoloViews.
Thanks.
Like hreflot. Alrighty, thank you.